Good morning everyone. In the last video we have discussed about the nature of light, and there we have studied that duality, that means light have the dual behavior, that means the property of wave as well as the property of particle both are shown by the light. So light can show the behavior of particle as well as the behavior of the light. With the help of the different phenomena we try to explain that. We have also studied about the photoelectric effect. Now we are going to study about the Bohr's atomic model. What was the Bohr's atomic model? After these of the facts, after the nature of the light, after the nature of the energy, whatever we have studied, what model Bohr gave to us. Bohr says that there is a nucleus in the center which contains almost all the mass whatever the atom is carrying. That means that contains proton and neutron. Actually, this nucleus concept was given by Mr. Rutherford. Whatever the experiment he had done, that experiment was suggesting that there is a nucleus in the center which have a very heavy density and almost all the mass. So according to Bohr, again the nucleus is there in the center and all the electron rotates around it, as it was said by the Rutherford, but not in general orbital, not in regular orbital. These of the electrons are rotating in very much definite orbital, that is called the discrete orbital. So electrons are moving in the discrete orbitals around the nucleus, having very much fixed energy. These are the these are the orbitals were called K, L, M, N, etc. So according to Bohr, there is a nucleus in the center and electron rotates around it in the different discrete orbitals. When you will think, you will find that the atomic model of Bohr is almost similar to the atomic model of the Rutherford. Then why the Rutherford's model was not correct? Why the Bohr's model is correct? Actually, the Rutherford model was not capable to explain the stability of the atom. Why the atom is stable, he was not capable to explain. But Bohr's atomic model is capable to explain the stability. In the Bohr's atomic model, we have said that according to Maxwell, when any charged particle moves with the accelerated motion, it emits radiation. And because of the emission of the radiation, the energy of the electron becomes lesser and electron finally collapse with the nucleus. That is, the destruction of atom takes place. But when you will see these of the discrete orbital means the definite orbital, very much fixed energy of orbital, then electron can move in these of the orbital, cannot move in between these of the two orbitals. So by taking one quanta energy, the electron can jump from lower energy to higher energy, and by using one quanta energy, that can jump from the higher energy to the lower energy. But they cannot survive in between these of the orbitals. And because of the reason, no radiation is possible moving in these of the discrete orbital. So according to Bohr, as the electrons are moving in the discrete orbital, they are not capable to emit any of the radiation, they are not capable to lose any of the energy, and because of the lack of loss of energy, the electrons are not going to collapse with the nucleus, and because of the reason, the atom becomes stable. So this was the only difference in between these two, Rutherford and Bohr's atomic model, that Rutherford was saying that the electrons are rotating around the nucleus in regular energy values. But Bohr says that energy is not a regular energy value, they are the discrete energy value, and this is the reason why the electrons are not rotating anywhere around the nucleus, they are rotating in definite discrete orbital, and that was the Bohr's atomic model. Till the time, this was the best model. Even in the modern time, whatever we need to discuss, we discuss on the basis of the Rutherford's atomic model. The next thing, when we talk about the chemical and physical property, how we will discuss about the chemical and physical property. In the 9th standard, you have studied about the Bohr-Bury scheme of the electronic configuration, electron distribution. That means he was also capable to say that what will be the distribution of the electron. He said that any of the orbital can contain maximum of 2n square electrons, where n was the principal quantum number. The valence shell can contain maximum of 8 electrons. The inner shell can not contain more than 18 electrons till the inner orbital does not have the completely filled condition, etc., etc. There were few rules which were dealing with the Bohr-Bury scheme. That means he was capable to say that what will be the distribution of the electron, and on the basis of the distribution of electron, on the basis of the electronic configuration, he was capable to explain the chemical as well as the physical property of the element. So you can say that this was the best model till that date. He was capable to explain the stability, chemical property, physical property, almost everything. So if he is saying that the energy of all of these of the orbital is definite, discrete orbitals these are, so they have the definite value of energy, then what will be the value of these of the orbitals? So according to Bohr, the energy of any of the orbital, E for the nth orbital, you can say E equal to RH. This RH is called the Rydberg constant, okay, having value 2.18 into 10 to the power minus 18, called Rydberg constant. Then E equal to RH Z square upon N square, where Z is atomic number and N is principal quantum number. So Z is the atomic number and N is the principal quantum number in this one. So energy of any of the orbital E equal to RH Z square upon N square. But if the excitation of electron is taking place, that means the electron is exciting from one energy level to another energy level, then what will be the energy difference? जनरली तो हमें यही पता करना पड़ता है ना कि फर्स्ट ऑर्बिटल से सेकंड ऑर्बिटल में, फर्स्ट ऑर्बिटल से फिफ्थ ऑर्बिटल में, फोर्थ ऑर्बिटल में, थर्ड ऑर्बिटल में, इन विच ऑफ द ऑर्बिटल दैट इज जंपिंग कितनी एनर्जी रिलीज होगी या कितनी एनर्जी कंज्यूम की जाएगी. सो फॉर दैट वी गिव द फार्मूला एज वी न्यू फॉर द orbital number 1, if the E initial, you can say initial orbital's energy, then RH equal to Z square upon Ni square, that is the principal quantum number initial in which the electron was initially there, and E final, energy of the final orbital equal to RH Z square upon N final square. In your book, instead of Ni and Nf, it is written N1 and N2. I am talking about the NCERT book. So what will be the energy difference? Delta E equal to energy of the final orbital minus energy of the initial orbital. Just we are trying to find it. Delta E equal to RH Z square N upon F square minus RH Z square 1 upon Z square upon Ni square. Just by solving this, you will find delta E equal to RH, which is common in these of the two values. Z square 1 upon Nf square minus 1 upon Ni square. This is the Nf square, this is the Ni square, and this is the energy needed for the transition of electron from one energy level to another energy level. That may be the transition from the lower energy level to the higher energy level, or from the higher energy level to the lower energy level. As we have discussed the energy of the orbital, जैसे बोर ने किसी भी ऑर्बिटल की कितनी एनर्जी होगी ये बताया, वैसे रेडियस की भी तो जरूरत पड़ेगी कि किसी भी ऑर्बिटल का रेडियस क्या होगा. सो ही सेज दैट रेडियस इक्वल टू 52.9 n square by z. The value is in picometer. I think you knew well about the picometer. 1 picometer equal to 10 to the power minus 12 meter. Then this is the radius for any of the orbital. That where n is the principal quantum number, that means the cell number you can say, and z is the atomic number. This was the model given by the Bohr. Even Bohr have given their best. At that time the model was the one of the best model till the date, though the model have lot of problems. Some of the problems which were solved by some of the rules, some other problems were not solved. So in the next video we will discuss that what was the problem with the Bohr's atomic model, what was the demerit with the Bohr's atomic model, and how the next model solved that. Till then, thank you, have a nice day, bye.